Hello everyone, my name is Mayur Ubale. I am Assistant Professor in Civil Department, WIT Solapur. Today we are going to understand and design the rapid sand filter. So there will be two parts. In first part we will be talking about the half and first part of the design, and in the latter part we will talk about the next part. So what are the learning outcomes? At the end of this session, students will be able to analyze the design of rapid sand filter in water treatment plant. So let us have few brief about the rapid sand filter. So you can see the water which is coming from the top will be transferring to the sand, and then it will be percolating to the gravel, and then it will be taking out from the laterals, and then it will be pushing towards the manifold, and at last the water will be taken from the manifold to the next unit. There is a process called backwashing which is also take place in the same process. After the filtration, we provide a particular time so that whatever the flocks which have been got blocked in this sand and gravel will be taken out through the backwashing. So it may be around half an hour or 1 hour. So as per our design. So this is the overall view of rapid sand filter. So there are various lookouts, what we can say, when we are thinking about the design of rapid sand filter. That is the filter tank, what is its size, what will be its height, length and breadth. Then what will be the how many laterals will be provided, what are their sizes, what is the perforation size, even what is the depth of gravel, what will be the depth of sand. All these things we will be talking in this rapid sand filter design. So let us have the design. The question will be design a rapid sand filter for a town having a total filter water requirement of 5 million liters of water per day. Assume suitable data. So there will be 6 parts under which we are designing. First one will be design of filter units, then estimation of sand depth, estimation of gravel and size gradation, design of under drainage system, then compute a dimension of wash water trough, computation of total depth of filter box. The first 3 parts we will be talking today. So first one is design of filter units. First we have to assume quantity of backwash water used will be 3% of filter output. So automatically the filter water which is required per day will become 1.03 multiplied by 5. So it will come 5.15 mld. So we also have to assume the time lost required for backwashing. So that will be 30 minutes. So you have to reduce the time from the total time period of the day. So and the quantity of filtered water will be calculated, and it will be coming, that is 5.15 divided by 24 minus 0.5, that is 30 minutes, which will be coming about 0.219 million liters per day. Now we have to assume the rate of filtration of a design. So automatically it will coming towards 5 meter cube per meter square per hour. We can take up to 6. So automatically the filter area will come out to be 0.219 multiplied by 10 raised to 6 divided by 5000, and it is coming about 43.83 meters square. We have to provide 2 filter units for the particular area. We must provide the 2 minimum filter units. Suppose one gets failed or one have some maintenance issues, other can be run for a particular emergency condition. And in this fashion, even we also divide the discharge. So for particular area, we have to divide and provide the filter units with respect to the particular design discharge. Now as we know the area, we can fix up the length and breadth using the range, that is 1.25 to 1.33 raised to 1. That will be L by B ratio. So I am taking 1.25 raised to 1. So length into breadth is 43.83 meters square, that is my area. Using the range, 2 multiplied by 1.25 B into B will become 43.83 meters square. So B will come up to be 4.05 meters. I can also say 4 meters. And length will be coming about 1.25, that is this ratio, multiply by 4.05, our breadth will be coming about 5.5 meter. So what will be my size of filter unit? That is 5.5 meter into 4.05 meter. I am talking about only one filter unit. Okay, the same area will be applied to another filter unit also. Coming to the second point, that is estimation of sand depth. What I will do, I will first assume the depth of sand, that is 60 centimeters. So what is the range? That is 60 centimeters to 90 centimeters. And what will be my effective size of sand? I will take 0.55. What will be the range? 0.35 to 0.6 mm. So the depth can be checked against the breakthrough of flock through sand bed by calculating the minimum depth required by Hudson formula. So what is the formula? That is Q into D cube into H divided by small l, that is depth of sand bed, is equal to Bi into 29323. Here Q, that is my rate of filtration, will be 5000 liters per hour per meter square multiplied by 2, as there are 2 filter units. So what is the final value? That is 10,000 liters per hour per meter square. That is the worst condition for maximum daily demand, which is the required condition for any design of any filtration unit. So that is why we always take 100% overloading under emergent conditions. Now, as we know the depth, that is 0.6 mm, which we are assuming, H, that is terminal head loss, that is 2.5, L, that is depth of sand, which we have assumed, and Bi, that is 4 into 10 raised to minus 4, that is what we are assuming for poor response of filtration and average degree of P treatment. So we are putting these values into the equation, that is Hudson's formula's equation, and we will be getting L is equal to 0.46 meter or 46 centimeter. So what we have assumed? We have assumed 60 centimeters. But what is the value coming? That is 46 centimeters. That is, our assumption is very much good, so as to remove off, or what we can say, avoid the breakthrough of flock. So what we will doing? We will be keeping the depth of sand to be 60 centimeters. Coming to the third point, that is the size gradation of gravel. We are going to see how the variation of size is there, and with respect to that, what are the depth of particular variation size is given to the gravel. To do that, what first we will assume is size gradation of gravel to be varying from 2 mm, that is on top. You can see on the right hand side diagram, at the top of the gravel there is a 2 mm, that is at the top, and at the bottom there is a 40 mm. In the diagram you can also see slowly the gravel size is increasing, that is variation of gravel is there. So with respect to that, we have to fix up the depth of the gravel with respect to their particular size, and to do that we are using the formula, that is L is equal to 2.54 dot K log D, where D is the effective size of gravel and K is a constant. You can vary the constant, that is K, from 10 to 14. I am taking 12 here. So L will be 2.54 into 12 into log D, which will be coming about 30.48 log D. Now what I will do? I will put the values of gravel varying from 2 to 40. So first I will do for diameter of 2 mm. I will put the value of 2 into this equation, and what I will get? L is equal to 30.48 into log 2, which is coming about 9.2 centimeters. Now what is the implication of that? What does it mean? So you can see in the diagram now, 9.2 centimeters of depth is given for diameter of gravel of about 2 mm. So it means for the depth of 9.2 centimeters, the diameter of gravel will be of 2 mm. But what is the total depth of gravel with respect to the varying size? This is only for 2 mm. Now I will talk about variations of the gravel. For 2 mm it is coming about 9.2. What is the increment? It will keep be same, that is 9.2. For the 5 mm it will be coming about 21.3. So increment will be 21.3 minus 9.2. So that is coming about 12.1. Similarly, I will do for 10, 20 and 40, and it will be coming about 9.2, 9.2 and 9.1 respectively. So you can see here in the right side, for the variation of diameters of gravel, the depth is changing. And what is the final amount of depth which is coming? That is 48.8. So that is my absolute value. So what I will do, I will fix up the depth of gravel to be 50 centimeter. That is the final value. So what I will do, I will keep, you can see here, I will keep the depth of gravel to be 50 centimeters. That will be my absolutely final value of depth of gravel below the sand. So let us have few review questions. First, in rapid sand filter, minimum 2 filter units are provided, whether it is true or false. Then quantity of backwash water used is dash of quantity of filter output. Then the third one is maximum depth of sand provided in rapid sand filter is, that is 60 or 70, 80 or 90 centimeters. So what are the answers of the same? In rapid sand filter, minimum 2 filter units are always provided. Quantity of backwash water used is always 3% of quantity of filter output. And maximum depth of sand you can provide in rapid sand filter is always 90 centimeters. That is 60 centimeters to 90 centimeters. That is the range. These are the books I have used for the making of this presentation. Thank you.